welcome to review video number 5. I don't even know anymore. Today we're going to talk about all things binary, and I'm having to do review myself because I forgot all the little details about this. So stay tuned for some reminders and then some problems. Okay. Things first, you probably should know how to recognize if you're in a binary setting or not. So remember, binary is when we did bins for the first part of binary. First thing that we talked about is it a success-fail situation? So are you looking for the probability of a success-fail situation? Is each roll of the die or flip of the coin, well, not roll of the die, flip of the coin, independent of the next one? Is your problem a fixed number of trials? So did they tell you in advance you're going to flip a card and find out if it's red 12 times? Okay, so is it fixed? And then, do you have the same probability every time? So we're talking about every time with replacement, right? So that you're not changing the probability. So these are the questions you ask yourself before you ever dive into the binary formula. Okay, hang on. You've decided that you are in a binomial setting, then you're going to go to the formula. The formula is on the formula sheet. Don't forget on the AP test, if it's an open response question, which I fear because it hasn't happened in a while, that they're going to ask a binomial open response question. So here's what the formula looks like. On the actual AP exam, you would want to use this formula and show how you can use it by plugging it in. But you can use the calculator functions, which I added here. So you can see this binomial probability formula. The probability of k successes occurring would be n choose k, where it's n is the fixed number of trials, k is how many successes there are, times p to the k power, where p is the probability of each event occurring, times 1 minus p to the n minus k power. Okay. Also remember that n choose k is n factorial over k factorial times n minus k factorial. Let me get a little closer here. If you want to find exactly k successes, you would use binom PDF. Remember, P stands for point, so it's only one point that you're looking for. Then you also have binom CDF, which is the cumulative function, and it gives you the probability that it's less than or equal to k trials, okay? So remember, if you're looking for greater than k trials, then you would have to do 1 minus this value to get the greater than probability, okay? So I tried to choose actually some open response questions this time just because I'm so worried that the AP is going to have one. And I picked some tough ones that are kind of hard to tell they're binomial so that we can talk about this, okay? So the one you're about to see is about an automobile company, and so the first part is just the table. So take a second, read the problem, okay? Just the prompt itself, nothing about the prompt tells you that it's binomial. So let's look at the first question. So we need an expected value and we need a standard deviation. So the first question you should be asking yourself is, how is this binomial? Because it doesn't seem binomial. So let me give you the first part of this is you check bins and you think, okay, so is it a yes or no? Yes, it's a yes or no. Like, yes, it's E. No, it's not E. So there's a yes or no on bins. But then you go to the, are they independent? And do they have the same probability? And you think, no, because you are replacing, right? So if you pick an E, it's gone. You pick an E, it's gone. The trick with this one is that you have a huge sample size, right? So it's something like 100 times larger, the total is than E itself. And so because the sample size is so large compared to E, then it's fine for there not to be replacement because the probability doesn't change enough for it to affect it very much. And maybe we talked about this, I can't even remember, but basically the rule of thumb is if it's 10 times larger, if the sample size is 10 times larger than the specific thing that you're talking about, then you can kind of say, it's okay that it's not independent. And it's okay that they don't have exactly the same probability because of the large sample size. And then n is the fixed number of trials, and we have 2,000 of those. Once we decide that it's binomial, then we probably want to reference our formula sheet to find out what is expected value formula, and then also what is the standard deviation formula for binomial. So let me pull that up. Hang on just a second. You can see there's an entire section devoted to binomial, but the expected value is expected value no matter what we're talking about. So the formula for expected value is trials times probability, right? And the sum of them. In this case, when it's binomial, we can just multiply them. So we need a p. So the probability of E is just 2323 out of the population, or out of the sample, or whatever it is. And so then you've got 0.0078 as your p-value, and I can just multiply that times 2,000 and get my expected value. I imagine this one most people would get. You do have to talk about bins in order to be able to talk about the next part, though. So you needed to have reference bins and check your settings clearer than I did here, of course, but you have to talk about, is it binary? Is it a fixed number of trials? Is it independent? And then also, does each trial have the same probability? And if not, why? Okay, so then you reference the formula sheet. Absolutely, you're not going to have this memorized. I definitely don't. And it's just n times or square root of n times p times 1 minus p. I plug my numbers in, and I end up with a standard deviation of 3.94. Okay? All right, so let's look at the next part of this problem. Hold on. The question is when selecting a simple random sample of 2,000 new car owners, how likely is it that fewer than 12 owners of Model E would be included in the sample? Okay, so you already know the probability of choosing E, and we're still talking about that 2,000, right? And just so we're clear, you actually can use z-scoring on this problem. So if you want to use a normal distribution on this problem, you can. Just make sure you check conditions for probabilities, which hopefully we've done enough that I don't have to review here, okay? But there are 3 thoughts that you should have here if you're going to use binomial, right? You know you're going to have to use a binomial formula for 0, for 1, for 2, for 3, for 4, 5, 6, 7, 8, 9, 10, and 11, okay? And so it says fewer than 12, yeah, so all the way up to 11. And so you're either going to write that formula all those times, which I hope you don't do, okay? Or you can show a summation. So you could show a summation for 0 to 11, 2,000, choose X, right? Because you're going to choose 0, 1, 2, 3, 4. That's what the summation symbol means. Times P to the X. 1 minus p to the n minus x. Well, 2,000 minus x because we're using n. So you can use this and then just type into your calculator. Or you can write the first one and then ... write the last one. Regardless, and I shouldn't have done or here actually, let's take that or out. You have to show that you use the binomial formula somehow, okay? Now to get your actual probability, you can just really go to the calculator and use that binomial CDF. Remember, cumulative would be everything all the way up to 11 because of that less than or equal to. And then that gives you a probability of 0.147. Okay, so this is part B. Again, you can use normal distribution, which is where my brain went at first, but PDF binomial is also likely. Okay, so let's look at part C. All right, and even if you didn't get any of the other parts to this question, this is certainly a completely reasonable way to get points for this problem. So it says the company is concerned that a simple random sample of 2,000 owners would include fewer than 12 owners of Model D and Model E, okay? So that makes sense because that probability was so low for E. So we want to describe a sampling method for randomly selecting 2,000 owners that ensure that you're going to have at least 12 in each group, right? Excuse me. So the obvious sampling here is stratified. So to get any points on this, you're going to have to say stratified, right? So I'm creating these groups. I'm going to pull from each of these models, okay? Then there are things that you have to do to ensure that you're describing your sample. So you might be tempted to just put stratified without actually describing how you would do this stratified. So let's talk about what you need. You need to say in your explanation that you're going to take at least 12 owners from each model, ensuring a sample of 2,000, okay? So I fear that if you were to leave off 2,000 in your explanation, that you would not get essentially correct in this problem. At one point, you say random, because if you don't say random in your explanation, there's no way you're going to get essentially correct. Even if you say stratified, and even if it said random in the prompt, you still have to say random. And then last, and this is the part that I actually didn't do when I answered this question at first, is to get it essentially correct, you actually need to go through with probabilities and determine how many people you would need from each group to get 2,000, okay? Keeping about the same probability, making sure D and E have at least 12. So in there, well, I don't have it pulled up anymore, but you can actually go through and determine those probabilities. This is 2010 question number 4 if you want to get